The December cold bites through the flight suit as Captain Marcus Webb climbs into the cockpit of his P-38 Lightning at Foggia Airfield in southern Italy on December 22, 1943. His breath forming clouds in the pre-dawn darkness that will soon give way to another mission deep into German-held territory. The twin Allison engines turn over with their characteristic rumble, a sound that has become as familiar to him as his own heartbeat after 6 months of combat operations over the Mediterranean theater. Painted on the nose of his aircraft are 17 small swastikas, each representing a confirmed kill, each marking a moment when skill and luck converged to produce survival rather than the alternative. Webb's ground crew chief, Master Sergeant Daniel Kovacs, stands on the wing beside the cockpit, leaning close to be heard over the engine noise, pointing to the propeller control levers with an expression that mixes concern with something approaching defiance. The propellers on Webb's Lightning have been set to a pitch angle that the technical manual explicitly prohibits, that Allison Engine Company engineers have never approved for combat operations, that violates standing orders from the 82nd Fighter Group's maintenance officer who has threatened court-martial for any crew chief who implements unauthorized modifications. The setting increases blade angle beyond the fine pitch position used for takeoff and the coarse pitch position used for cruise. Entering a range, the manual marks in red with warnings about structural stress and engine overheating. Kovacs has been implementing this unauthorized setting on Webb's aircraft for the past 2 weeks, ever since Webb returned from a mission reporting that German interceptors were catching him in situations where the P-38 should have had speed advantage, where textbook propeller settings were proving inadequate against opponents who seemed faster than intelligence assessments had predicted. What happens during this mission will demonstrate that sometimes the manual is wrong, not because engineers made mistakes, but because combat reveals performance requirements that peacetime testing never anticipated. Will prove that 18 additional knots of airspeed can mean the difference between interceptor catching bomber escort and bomber escort outrunning threat, and will force the same maintenance officers who threatened court-martial to acknowledge that unauthorized modifications achieving mission success matter more than authorized settings, producing inadequate performance. To understand why Webb and Kovacs believed that violating propeller pitch limits would improve rather than damage performance, one must first comprehend what those limits were designed to prevent, and why engineers who established them were simultaneously correct about the physics and wrong about the operational trade-offs. The propeller on a World War II fighter was not simply a spinning blade, but rather an adjustable airfoil whose pitch angle determined how efficiently it converted engine power into thrust. Fine pitch, small blade angle relative to the plane of rotation, was optimal for takeoff and climbing. Where high RPM and maximum power were needed, coarse pitch, larger blade angle, was optimal for high-speed cruise. Where efficiency mattered more than maximum power, the P-38's Curtiss electric propellers could be adjusted in flight through a range of pitch angles, allowing pilots to optimize performance for different flight regimes. But the adjustment range had limits, and those limits existed for sound engineering reasons. Excessive coarse pitch could overload the engine, could create propeller blade stresses that exceeded structural margins, could generate vibrations that would cause progressive damage, accumulating over hours of operation until catastrophic failure occurred. The red-lined sections of the propeller control range were marked red because exceeding those limits risked immediate or progressive damage that could kill pilots who pushed beyond what engineers had determined was safe. Webb had come to fighter aviation through engineering background that made him question rather than accept technical limits when operational experience suggested those limits might be conservative. Before the war, he had studied mechanical engineering at Cornell, had worked briefly for Pratt & Whitney designing engine components, understood the difference between absolute physical limits and safety margins that engineers included to account for manufacturing variations and pilot error. When he flew combat missions and found himself being overtaken by German fighters in situations where the P-38 should have had speed advantage, he began analyzing why performance was falling short of specifications. The P-38 was theoretically capable of 400 miles per hour in level flight at optimal altitude, fast enough to outrun most German fighters. But in practice, at the altitudes where bomber escort missions operated, with the tactical loads aircraft actually carried, with engines that had accumulated hundreds of combat hours rather than being fresh from the factory, actual top speed was closer to 360 miles per hour. German Bf-109G and FW-190A fighters, which intelligence assessments said were slower than P-38s, were catching American escort fighters in stern chases that should have been impossible if the American aircraft were actually achieving their rated performance. The theory behind the unauthorized propeller setting that Kovacs implemented was based on understanding that the red-lined limits were designed for sustained operations rather than emergency performance. Engineers who established those limits were thinking about engine longevity, about preventing damage that would accumulate over hundreds of hours of operation, about ensuring that aircraft could complete their expected service lives without catastrophic failures. But combat operations changed the calculus. An engine that failed after 200 hours instead of 400 hours was still acceptable if those 200 hours included successful mission completions that would have been impossible with conservative settings. A pilot who could outrun interceptors by pushing his engines beyond red-lined limits might accept reduced engine life as reasonable trade-off for increased survival probability. The unauthorized coarse pitch setting Kovacs used increased blade angle to the point where the propellers were operating at the absolute edge of their structural capacity, where vibrations were generating stresses that would eventually cause fatigue failures, but where the increased efficiency of the blade angle at high speed allowed the engines to push the aircraft 18 knots faster than standard settings permitted. The sound of the Allison engines at unauthorized pitch became the symbolic element that defined what this modification represented, a deeper, harder tone than the normal cruise setting produced, a sound that vibrated through the airframe in ways that standard operations did not. A mechanical voice that announced to anyone who understood engines that something was operating outside normal parameters. That sound was not the smooth, reassuring rumble of engines running within their comfort zones, but rather the strained intensity of machinery being pushed to its limits, of components tolerating stresses they were designed to handle only briefly rather than continuously. For Webb, that sound became associated with survival, with the margin of speed that allowed him to position his aircraft where tactics required rather than where limited performance forced him, with the difference between catching enemy fighters before they reached bombers and watching them slip away because 18 knots of missing speed made interception impossible. The mission on December 22nd was bomber escort to Klagenfurt in Austria, where industrial targets supporting German aircraft production operated under heavy fighter defense. The bomber stream consisted of 72 B-17s from the 5th Bomb Wing, flying in combat boxes designed to provide mutual defensive fire while making coordinated attacks possible. Webb's P-38 squadron provided close escort, positioning themselves within visual range of the bombers, where they could respond immediately if German fighters penetrated the screen of P-51s and P-47s flying high cover. The formation crossed into German-controlled airspace at 09:15 hours, climbing through scattered clouds toward the 25,000-foot altitude where the attack would be conducted. German controllers tracked the raid from first penetration, vectored interceptor units toward positions where they could attack bombers during the vulnerable minutes when bomb runs required straight and level flight. The interception came at 10:03 hours as the lead bomber group began its approach to the target, 6 Bf-109G fighters diving from 30,000 feet toward the bombers, their tactics reflecting the experience of pilots who had survived months of combat against increasingly capable American escorts. The German fighters did not attempt to engage the P-38s directly, but rather used their altitude advantage to build speed in vertical dives that would carry them through the fighter screen faster than escorts could react, allowing brief firing passes on bombers before climbing away under power before American fighters could pursue effectively. Standard response for P-38 pilots was to climb to intercept, to position themselves between the diving Germans and the bombers, to force the attackers to maneuver around escort fighters, rather than having clear runs on their intended targets. Webb began his climb immediately, advancing throttles to maximum power, adjusting propeller controls to the unauthorized course pitch setting that Kovacs had set before takeoff. The transformation in how his aircraft performed was immediate and unmistakable, where standard propeller settings would have allowed perhaps 370 miles per hour in the climb. The unauthorized setting pushed speed to 388 miles per hour, 18 additional knots, that translated to covering the vertical distance between his position and the German fighter's dive path, 3 seconds faster than textbook performance would have achieved. 3 seconds in air combat is not merely measurement of time, but rather the difference between arriving in position to disrupt an attack and arriving too late to prevent bombers from taking damage. Webb reached interception position as the lead Bf-109 was still 500 yards from firing range on the nearest bomber, his P-38 appearing where German pilots had calculated no escort fighter could possibly be based on their intelligence about American aircraft performance. The German formation scattered, individual pilots breaking off their attack runs to evade the escort fighter that had appeared impossibly early in their attack sequence, abandoning coordinated tactics for individual survival. The engagement that followed demonstrated not superior flying skill or better tactics, but simply the advantage of speed that opponents had not anticipated. Webb pursued the nearest Bf-109 as it broke left and dove away. The German pilot, confident that his fighter could outrun the pursuing P-38 in a dive, because previous encounters had taught him that P-38s were fast in level flight, but not particularly faster than German fighters in descending flight. The confidence was misplaced. Webb's Lightning, running at unauthorized propeller pitch, and therefore generating thrust more efficiently at high speed than standard settings allowed, closed the distance steadily. At 1,500 feet separation, Webb was within effective firing range. At 1,000 feet, he achieved the deflection angle needed for a high-probability shot. The 50 caliber machine guns in the P-38's nose, all 4 of them converging on a single point, fired a 2-second burst that produced strikes along the Bf-109's fuselage and wing route. The German fighter began trailing smoke, its pilot rolling inverted and diving away vertically in a desperate attempt to escape what had become a losing engagement. The sound of Webb's engines during the pursuit, that deep, strained roar of Allison's running at unauthorized pitch, was the audible manifestation of performance that should not have existed according to approved operating procedures. The German pilot could not hear that sound over the noise of his own engine, could not know that he was being outrun by an American fighter that was violating its own technical limitations, could not understand that the P-38 closing on him was achieving speeds 18 knots faster than intelligence assessments said were possible. But the result of that performance was undeniable. The Bf-109 pilot ejected at 8,000 feet, his aircraft uncontrollable. The engagement lost, not because he had made tactical errors, but because his opponent's aircraft was performing beyond the capabilities that tactical planning had assumed were maximum. The transformation visible in how the mission unfolded after Webb's interception was that the remaining German fighters, having watched their leader shot down by an escort fighter that appeared faster than their briefings had indicated was possible, abandoned their attack on the bombers entirely. The coordinated tactics that had been planned to overwhelm escort defenses through multiple simultaneous attacks became individual survival as German pilots recognized that their intelligence about American fighter performance was wrong, that engaging P-38s in situations where they had expected speed parity might actually result in American speed advantage. The bombers completed their attack runs without further fighter opposition, dropped their ordnance on target, and turned for home with losses from flak, but 0 losses from fighter attack, a result that seemed routine when tallied in after-action reports, but that reflected the cascade of effects that began with 18 additional knots of unauthorized speed, allowing one escort fighter to arrive in interception position 3 seconds earlier than German attack planning had accounted for. The resistance Webb and Kovacs encountered after the mission, when maintenance officers discovered the unauthorized propeller settings during post-flight inspection, reflected institutional priorities that valued compliance over effectiveness when effectiveness violated established procedures. The group maintenance officer was explicit. Unauthorized modifications were prohibited regardless of their results. Engines were to be operated within specified limits, regardless of whether those limits proved inadequate for operational requirements, and crew chiefs who implemented unauthorized settings faced disciplinary action up to and including court-martial. The engineering arguments supporting the prohibition were sound. The unauthorized pitch setting was generating propeller blade stresses that exceeded design margins by 12%, was creating vibration patterns that would cause progressive fatigue damage, would reduce engine service life by approximately 40% if used continuously. Those calculations were accurate and properly supported by engineering analysis. What the calculations did not account for was whether reduced engine life mattered when the alternative was reduced pilot life, because inadequate speed made mission completion impossible. The transformation in how the 82nd Fighter Group approached propeller settings following Webb's successful interception began not with official policy changes, but with quiet adoption by pilots who heard about the results and asked their crew chiefs to implement the same modifications. Within 2 weeks, more than half the P-38s in the group were operating with unauthorized course pitch settings, their pilots reporting successful interceptions in situations where standard settings would have resulted in German fighters penetrating to bombers before escorts could react. The maintenance officer, confronted with widespread violation of the prohibition he had established, faced a choice between enforcing discipline that would reduce operational effectiveness or accepting that unauthorized modifications were achieving mission success that approved procedures could not match. His decision to request formal testing of the unauthorized settings, rather than simply court-martialing everyone involved, reflected pragmatic recognition that winning the war mattered more than enforcing technical compliance when compliance was proving inadequate. The formal testing conducted by Allison Engine Company engineers in early 1944, using data collected from combat operations where unauthorized settings had been employed, revealed what Webb and Kovacs had discovered through operational experimentation. The red-lined propeller pitch limits were conservative, established with safety margins that were appropriate for training operations and peacetime flying, but that were unnecessarily restrictive for combat operations where engine life could be traded for performance. The engineers concluded that the unauthorized settings could be safely employed for limited durations during combat, that the performance benefits outweighed the reduced engine longevity, and that formal operating procedures should be revised to include the previously unauthorized settings as approved options for emergency use. The revision was bureaucratically awkward. It required acknowledging that established limits had been wrong, that unauthorized field modifications had identified performance capabilities that factory testing had not discovered, that pilots and crew chiefs operating under combat conditions sometimes understood their equipment better than engineers operating under test conditions. The 18 knots of additional speed that the unauthorized propeller setting provided was 18 knots that translated to mission success rather than mission failure in dozens of engagements throughout early 1944. Combat reports from the 82nd Fighter Group show a marked increase in successful bomber defense missions following adoption of the modified settings, show a decrease in bomber losses to fighter attack during periods when escorts were using unauthorized pitch, show German after-action reports expressing confusion about why American escort fighters seemed faster than previous encounters had indicated they should be. The speed advantage was not overwhelming. 18 knots is less than 5% of cruise speed. But air combat is decided by margins measured in seconds and yards rather than minutes and miles, and 5% speed advantage means arriving at interception positions before opponents expect escort fighters to be present, means catching diving attackers before they reach firing positions, means converting defensive situations into offensive opportunities through performance that opponents had calculated should not exist. The sound of those Allison engines running at unauthorized pitch, that deep, strained roar that announced machinery operating at its limits, became the audible symbol of what separated those who followed rules from those who understood when rules should be broken. That sound was not rebellion for its own sake, or reckless disregard for safety, but rather calculated decision that operational effectiveness mattered more than technical compliance. When the two came into conflict, that survival in combat required using equipment to its actual limits rather than its approved limits, when approved limits proved inadequate for mission requirements. For ground crews who heard that sound during pre-flight run-ups, who knew the engines they maintained were operating outside approved parameters, who understood that every hour of operation at unauthorized settings brought engines closer to failure, that sound represented trust between pilots and mechanics, belief that the modifications they implemented would keep pilots alive, even if those modifications violated regulations and risked their own careers. And so we returned to that cold December morning at Foggia Airfield, to Captain Webb climbing into his cockpit, while Master Sergeant Kovacs points to propeller controls set to angles the manual prohibits, to the moment when compliance with regulations must be weighed against effectiveness in combat, when approved procedures must be compared with unauthorized modifications that achieve results approved procedures cannot match. The sound that follows as Webb advances, throttles, and propeller pitch enters unauthorized ranges, that deep, strained roar of engines pushed beyond their approved limits, is the sound of performance extracted through understanding rather than granted through authorization, the sound of machinery operated at its actual capabilities rather than its bureaucratically approved capabilities, the sound that announces someone has decided that mission success matters more than procedural compliance, when the two cannot be reconciled. The 18 knots of additional speed that unauthorized setting provides is 18 knots that means arriving 3 seconds earlier at interception positions. That means catching German fighters before they reach bombers, rather than watching them escape after inflicting damage. That means completing missions successfully, rather than losing bombers, because escort fighters lacked the performance needed to position themselves effectively. Those 18 knots, those 3 seconds, that small margin of performance beyond what regulations approved, cascade into mission success that saves bomber crews who never know how close they came to being shot down because an escort fighter appeared where German attack planning said no escort could possibly be. Appearing there not through superior tactics or exceptional skill, but through simple speed that should not have existed, according to approved operating procedures, but that existed anyway because one pilot and one crew chief decided that the manual was wrong about limits, and that combat would prove which understanding was correct. The resistance they faced, the threats of court-martial, the institutional insistence that compliance mattered more than effectiveness, all dissolved in the face of results that could not be disputed, missions completed that would have failed, bombers defended that would have been lost, German fighters intercepted that would have penetrated defenses, all because 18 knots of unauthorized speed converted theoretical performance into actual performance, and proved that sometimes the greatest innovation is recognizing that the manual's red lines mark where peacetime caution ends and where wartime necessity begins, that the sound of engines pushed beyond approved limits is the sound of equipment being used as it was actually designed to be used, rather than as bureaucracy approved it to be used, that survival belongs not always to those who follow regulations most carefully, but sometimes to those who understand when regulations must be exceeded, because the alternative is accepting inadequate performance, when adequate performance is mechanically achievable through methods that are unauthorized only because they violate limits established for conditions that no longer apply, when combat reveals what peacetime testing never discovered, that machinery can tolerate more than engineers approved, that pilots can extract performance that manuals prohibit, and that 18 knots of additional speed achieved through unauthorized propeller settings matters more than any court-martial when those 18 knots mean the difference between bombers defended and bombers lost, between missions completed and missions failed, between following rules that prove inadequate and breaking rules that prove necessary, the deep roar of engines announcing through sound what regulations could not acknowledge through text, that actual limits exceed approved limits when actual performance becomes necessary for mission success that approved performance cannot achieve,